For decades, we've been talking to our machines. We ask, they answer. But what happens when that conversation ends and the action begins? We are standing right at the edge of a fundamental shift in what intelligence even means. This is agentic AI.
For so long, the main interface has been language. We write a prompt, we ask a question, and we get an answer back. And don't get me wrong, that's a revolution in information. But it turns out it's only half the story. Because right now, a new paradigm is starting to take shape. It's one where AI moves from being a passive oracle to becoming a proactive partner. And this is the most natural and honestly, the most powerful evolution of intelligence. Going from just knowing something to actually doing something about it. So, let's explore this new frontier. We'll start with the action paradigm itself, then we'll break down the anatomy of an agent. We'll get to see this intelligence in motion, understand how it learns to act, talk about our responsibility in building it, and finally, see how it becomes this incredible multiplier for all of us.
Okay, so what is this shift really? Well, it's about moving beyond an AI that just gives you information to one that actually accomplishes goals. Think of it like this. It's the difference between asking for a recipe and having a system that can order the groceries for you and then preheat the oven.
And that gets us to the core of agentic AI. We're talking about systems that are proactive and totally goal-driven. They aren't just sitting there waiting for the next prompt. You give them an objective, and they autonomously plan, adapt, and carry out a whole series of actions over time to get it done.
To really get this, we kind of have to look under the hood. You see, an agent isn't just a single model. It's a dynamic system, a continuous process. So let's break down its core logic. Everything starts with a goal, which is defined by a person. From there, the agent works out a multi-step plan. Now, to execute that plan, it needs to select the right tools, things like APIs, web browsers, you name it. Then it takes an action, it observes what happened, and it uses that new information to improve its very next move. It's this continuous, intelligent loop of doing and adapting.
And this is where the difference becomes so clear. A chatbot is totally dependent on your prompt. It gives an answer, and then it stops. It just waits. An agent, on the other hand, is self-directed. It takes the initiative. It orchestrates a whole sequence of tasks to achieve a long-term goal. Okay, this is all still a little bit abstract, I get it, so let's make it concrete. Let's walk through a real-world example just to see this intelligence in motion.
All right, imagine giving an agent a goal like this. Create an efficient itinerary to visit all of Pittsburgh's art museums with minimal driving. Start from Shenley Park and log the final route in my travel repository. Let's see how the agent actually tackles this.
So, the first thing it does is break the problem down. The agent knows it needs to figure out which museums are art museums. So it picks a tool, in this case a web browser, goes to Wikipedia, parses the page, and pulls out a list of the right locations. It's gathering the raw data it needs.
Now that it has the list of museums, the agent has a new puzzle to solve. What's the most efficient route? So it grabs another tool, a mapping service, to calculate the best multi-stop route that minimizes driving time, just like we asked. This is the planning and orchestration phase.
And finally, the agent takes its optimized plan and performs the very last action. It accesses a code repository, finds the right file, and updates it with the final itinerary. And just like that, the goal is complete. It was achieved through a sequence of autonomous, tool-driven actions. Okay, now take the logic you just saw. Deconstruct, research, plan, execute, and imagine scaling it way, way up. At that level, these exact same principles can manage incredibly complex systems. We're talking about an agent that could coordinate global logistics, or optimize patient flow in a hospital, or run thousands of simulations to speed up drug discovery. But the real power here isn't just about getting tasks done. It's about getting better at them over time. So, how do these systems actually learn and adapt without someone having to step in all the time? Well, they use something called a learning loop. After an agent acts, it observes the outcome. Then it goes into a reflection phase, where it compares the result to its internal model of the world. It asks itself, did that action get me closer to my goal? This process of self-evaluation and course correction is what actually drives improvement. And this ability to self-correct is just a massive leap in efficiency. It means our role can shift. Instead of giving constant step-by-step instructions, we can set the high-level direction, the big goals, and the values. The agent can then handle the messy, iterative work of execution and refinement all on its own. Of course, with this level of autonomy comes a really profound sense of responsibility. The power that these systems have requires us to be incredibly deliberate and thoughtful about how we design them. One of the biggest technical challenges is something called goal misalignment. This is what happens when an agent takes an objective literally and pursues it in a way that causes some kind of unintended negative side effect. So, for example, an agent told to maximize customer engagement at all costs might just decide to start spamming users. It's technically fulfilling the instruction, but not the intent. But it's important to be clear here. These are not uncontrollable forces. These are engineering challenges. And we solve them through better design, through clearer value alignment, rigorous testing, and strong governance. It really is about building responsible systems from the very beginning. And as we get better at solving these challenges, the scope of agentic AI is expanding beyond the digital screen and out into our physical world. We're already starting to see this with agents that can perceive the world through a camera, understand what they're seeing, and then take physical action. This is the kind of intelligence that's going to power the next generation of robotics in healthcare, automate complex manufacturing, and guide autonomous transport. And this really brings us to the most important point. Agentic AI shouldn't be seen as a replacement for human intelligence. It is a powerful multiplier of human intent. It's a tool that lets us execute our most complex ideas at a scale and a speed that were just unimaginable before, extending our reach into the world. In the end, this evolution was always the true promise of artificial intelligence. It was never just about creating better search engines or more articulate chatbots. It's about building systems that can help us solve real, tangible problems out in the world. The future isn't about smarter words, it's about systems that can act responsibly on our behalf.